Welcome! Let's take a look at evaluating this antiderivative or indefinite integral. We have the integral of x squared times the quantity 2x squared minus 3 squared. Now, in its current form, we have no strategies for evaluating this integral or finding its antiderivative. What we can do, though, is use some algebra to take this integrand and rewrite it in a form that is more conducive to finding the antiderivative. So first of all, what we could do is we could square this quantity 2x squared minus 3, and then we could multiply that by x squared. So let's go ahead and take a look at what that might look like. So our integrand is x squared times 2x squared minus 3 squared. If it helps, you can think of this as x squared times 2x squared minus 3 times 2x squared minus 3. And we're going to go ahead and multiply this perfect square first. So when I multiply that out, I get x squared times 2x squared times 2x squared is going to give me x to the 4x to the fourth. 2x squared times minus 3 is going to give me a minus 6x squared. A minus 3 times 2x squared is going to give me another minus 6x squared. And then minus 3 times minus 3 will give us a plus 9. So we have x squared times 4x to the fourth. Our 6x squareds we can combine and we get negative 12x squared plus 9. And now we can distribute the x squared in through that new polynomial. And we get 4x to the 6th minus 12x to the 4th plus 9x squared. So what we can do is replace our original integrand with this new equivalent integrand. So now what we have is the integral of 4x to the 6th minus 12x to the 4th minus 9x squared dx. And now if I integrate that term by term, we have the coefficient of 4. The antiderivative of x to the 6th is x to the 7th, so we add 1 to the exponent and divide by that new exponent, so x to the 7th over 7 minus our coefficient is 12, and then the antiderivative of x to the 4th is, we'll need to add 1 to the exponent, so it'll be x to the 5th, and then divide by that new exponent, which would be 5. So we have x to the 5th over 5 minus, and that should be a plus. I copied that wrong. Over here, that is a plus, so let's make sure we have a plus. So plus, our coefficient is 9, and then our antiderivative of x squared, adding 1 to the exponent, we'll get x cubed, and then dividing by that new exponent, we get 3. And then we'll have plus our constant of integration. Now, looking across our antiderivative, looking for things that can simplify, the only thing I see that can be simplified is this denominator of 3 can divide into that coefficient of 9, and a 3 would be remaining. So our antiderivative here is 4/7 x to the 7th minus 12/5 x to the 5th plus 3x cubed plus c. I do hope you find this helpful.